Good afternoon, guys. It is Monday, and I hope you guys are being good for the substitute. So today we're going to do lesson 5-7, part 2. In part 1, remember, we had two equations that were both solved for y. Y equals 5x minus 2, and y equals 3x plus 4. And our goal was to see when would they equal each other. When did they cross? So you basically could take each of them, this y value, and plug it in for y, and this y value, and plug it in for y. Since y equals y, that would essentially eliminate one of our variables, and we could just solve for x. So today it's going to be very similar to that, but they're not both going to be solved for y. In fact, neither of them may be solved for y. So basically what we need to do is we need to look at our equations, okay? And we need to make sure that at least one of them is solved for one of the variables. At least one must be solved for one of the variables. It doesn't matter if it says x equals or if it says y equals. So of these two equations, one of them is already solved. We have this one that already has x equals a value. Now, if x is truly equal to this, then essentially you can replace any x value with that equation or with that expression because it's saying that it is equal to x. So instead of x, I am going to replace x with this expression. So let's go ahead and do that now. Substitute one equation into the other. So x minus 4y equals negative 9. And we said that x was equal to negative 7 plus 3y. So this still says x minus 4y equals negative 9 because that is a value that is equal to x. So next step, we're going to go ahead and solve our equation. So let's go ahead and start looking at this. If your problem has parentheses, use distribution and get them out of here. Well, there's nothing in front of here, or technically it's like a 1, so you're distributing a 1. So really it doesn't change those values at all. So negative 7 plus 3y minus 4y equals negative 9. All right, so now it says, when there are like terms, combine them too. Make sure the letters match before you do. So let's go ahead and look at these. Yep, those are both y's. So we can go ahead and solve this. We're going to say positive 3 minus 4 should be a negative 1y. And we can bring everything else down. Don't forget those negatives. They are very important. All right, so we still don't have y by itself, so now we got to decide, do we move this negative 7 first or the minus 1 that's getting multiplied? Remember, you always get rid of something that's being added or subtracted, so we're going to add 7 to both sides. And that leaves us canceling these 7's out, and we have a negative 1y equals a negative 2. When we divide by negative 1 on both sides, we finally find out what y equals. Y is equal to a positive 2. So now I'm going to take that y value of 2 and I'm going to put it down here in my solution. Remember, it's alphabetical order. X comes before y in the alphabet, X comes before y in an ordered pair. That is the y value, so please make sure that you put it on the correct spot of your ordered pair. All right, so now it says that we're going to take that y value and we're going to plug it back into either equation. I know this says that you have to plug it into the second equation, but you can actually plug it into either equation. Remember what I said last week. I always try to find the one that I think looks the easiest, the one with the least amount of negatives or fractions or anything like that. Well, when I'm looking at those two equations, to me, I think that bottom one looks a little bit easier, so I'm going to plug it back into the bottom equation. The bottom equation says x equals negative 7 plus 3y. Well, what did we say y was? We said that y was a 2. So we're going to plug in that 2 there and actually be able to see what does x equal. Well, 3 times 2 is 6. Negative 7 plus 6 makes a negative 1. So x equals a negative 1. So I can plug that into my solution. And those two equations should cross on a graph at negative 1, 2. It's supposed to make both of those equations true. So of course, you know with me, I've got to check my answers. So we're going to plug it back into both equations to make sure it works. First equation, x minus 4y equals negative 9. The second equation we said was x equals negative 7 plus 3y. Let's plug in our x value for x and our y value for y. So we have negative 1 minus 4 times 2. Well, negative 4 times 2 should be a negative 8. And negative 1 minus 8 does make a negative 9. So that is a true statement. Let's check the other equation. 3 times 2 is 6. Negative 7 plus 6 is negative 1. That is a check as well. All right, so right now I'm going to ask you guys to pause this video, and I want you guys to try the next system on your own or in your small groups, okay? And then we will come back after you guys have all had a chance to complete this. So go ahead and hit pause now, and then we can, when you guys are ready, you can press play and we will go over this problem. All right, so let's go ahead and check this. Now on this one, remember it says at least one of those equations must be solved for x or for y. In this equation or this system, the y is solved in this first equation. It says y equals. So I'm going to take that and I can plug it in for y. All right, so this one says 3x minus 4y equals 20. Let's take our y value, this negative 3x plus 10, and plug it in for y, because now it still says 3x minus 4y equals 20. All right, if your problem has parentheses, use distribution to get them out of here. So we're going to distribute this negative 4 to each item inside. Negative times a negative should be a positive 12x. Negative times a positive is a negative. 4 times 10 is 40. Bring everything else down. Okay. Combine your like terms. We have 3x plus 12x makes 15x minus 40 equals 20. Okay, do we get rid of the 15 or the 40? We're going to get rid of the 40, so let's add 40 to both sides. Canceling out our 40s. That leaves me with 15x equals 60. Divide by 15 on both sides. X equals 4. Now that I know x, again, let's put that into our correct spot in our solution. So remember, it's alphabetical order. So our x value is going to go right here. And now again, let's go ahead and plug that back into either equation. All right, so which one do we think looks easier? It's up to you. I personally think that the top equation looks a little bit easier. Y equals negative 3x plus 10. And we said that x was 4, so we can plug that 4 in for that x value. Negative 3 times 4 is a negative 12. Negative 12 plus 10 should be a negative 2. Y equals negative 2. So we're going to put that in our answer. And now let's check both equations. The first equation, y equals negative 3x plus 10. And the second equation, 3x minus 4y equals 20. Plug in our 4 for x, and it's supposed to spit out a negative 2 for y. Negative 3 times 4 is negative 12. Negative 12 plus 10 is negative 2. Yes, negative 2 does equal negative 2. That one's a check. Again, same thing here. We're going to plug in the 4 for x, and then negative 2 for y, and hope that it equals 20. 3 times 4 is 12. Negative times a negative is a positive 8. 12 plus 8 is 20. Yes, 20 does equal 20, so that one's a check as well. All right, so now I want you guys to go ahead and practice a few of these problems at your desks, so that way you guys can get some practice on this, and then we will talk some more tomorrow. Have a good day.